Here's the first side of your revision card. So let's hit off with our 3 key objectives. So we're going to learn during this video of Surds basic laws number 1. Okay, how do we learn the basic laws? Just like indices, so we can actually do the rest of the harder examples. Question number 2, how do we simplify different surds as well? You learn different techniques of how we can do these using square numbers, and how we can lastly do rationalizing the denominator, which basically means simplifying fractions where denominator is a surd form. So this is a grade 7. The latter ones get to grade 8. The topic is called Surds. This is week 14 on our silver topic list. We give you again examples for your best questions to write over here, so write these down on your revision cards, and hopefully we can create clear 3 steps 1, 2, 3 for you to understand as we go along this video. So let's turn over to our toolkit and make some space for your sections on the toolkits, please. So this is side 2 of the Maths memory card, and this shows 3 clear sections of your toolkit. So if you section this out into sections A, B, and C, it doesn't have to be in this size, but as long as you create 3 boxes to show your toolkits A, B, and C in this video. Question 1, back to basics. Simplify root 3 times root 3. So this is very, very simple. What we do with this, root 3 times root 3 is simply, we just multiply whatever we see in the square roots. So we have a 3 here and a 3 here. It happens to be the same number, which is even better for us, which is root 9. Okay, so the way we got root 9 is by doing 3 times 3. Root 9 is simply 3. Now, a little shortcut for this, if you look at basically the number inside here, which obviously is 3, and 3 here as well, guess what? This number will always be the number inside here and here, okay? We can go straight from here to here. Okay, so if you can see this, same concept, percentage of root 10 times root 10, it'll simply be 10, okay? Question 2, back to basics. Simplify 2 root 5 plus 6 root 5. So a little trick is this, to see every time we see a surd, think of it like a common unit, or in other words, like an x. If you are good at algebra, you'll be good at this. So we're going to separate these 2 things over here. This is like saying 2x plus 6x. That's simply 8x, but basically x is root 5. So the answer is, we could say 2x plus 6x is simply 8x, but let's write root 5 instead of, obviously, the x, and that's your final answer, 8 root 5. Question 3, back to basics. Press pause, write this question down, simplify this, and press play when you're finished. So simplifying 4 root 3 times 2. So again, it's very simple. This root 3 might as well be written as x. If you get stuck, it's 4x times 2, which is simply 8x, or 8 root 3. And that's your final answer for this. Question 4, back to basics. Press pause, write this question down, press play when you have finished. So simplify 24 root 7 over 3. So again, let's look at the root 7 over here. This is very similar to saying 24x divided by 3. When we have this scenario, you do 24 divided by 3, which is 8, 8x, or 8 root 7. That's your final answer. Very, very simple. Question 5, back to basics. Press pause, write this question down, press play when you're ready. So in this case, we're asked to simplify 2 root 2 in brackets squared. So let's put the terms as numbers and surds. So the number is 2 in yellow, and this green is a surd term over here. Now squared means you've got to actually multiply everything you see in the brackets by itself. So we might as well write this, 2 root 3, 2 root 3. Now, don't get confused with the actual crab claw method. This is not the crab claw method at all. This actually is something like this. We do 2 times 2 first. We multiply the whole numbers, okay, which actually is going to be 4, okay, and he times it by, because there's a times over here, root 3 times root 3. Root 3 times root 3 is simply going to be 3. So the way we got the 4 was to multiply the numbers, 2 times 2, and the way we got the 3 was to multiply root 3 times root 3. And the best way to understand this was to separate this into number and surd terms over here. 4 times 3 is simply 12, and that's our answer for this question. Question 6, back to basics. Simplify 5 root 3 times 2 root 3. So this question is fairly simple. It's all about dealing again with your numbers over here, which is your 5 and the 2 and the surds as well. So split these up. It's really helpful if you do this. It'll really help you out. So let's deal with the numbers as a red box and the surds, let's say, as a green box like we've always done. Let's do the first red boxes first, the numbers. So we simply times 5 times 2, which is going to be 10. And then we multiply root 3 times root 3, which is simply going to be 3. 10 times 3 is your answer. And there we go, 30. Question 7, back to basics. Simplify 2 root 5 times 3 root 3. So press pause, write this question down. Press play when you're ready. So we have 2 root 5 times 3 root 3. 2 times 3 are your simple numbers over here. And you're going to identify separately your surd terms, which are your root 5 and root 3. So this is slightly different because the surds are different numbers under the square roots. That's why it's different. Same concept though. Let's just put these as our terms over here. We simply do 2 times 3, which is 6, and root 5 times root 3, which is root 15. Simple as that, and that's your final answer for this. Question 8, back to basics. Simplify this expression over here and press play when you're ready. So the first thing we're looking at over here is the squared little power over here. So what you want to do is write this out twice. 2 plus root 3 and also another 2 plus root 3 over here. We have two brackets, so we're going to square each one. And this looks much more familiar. Okay, so we're going to do the crab claw method for this. We're going to do it as such. So let's do this. 2 times 2, that's the first step. Second step is 2 times root 3. Third step, root 3 times 2. Fourth step, root 3 times root 3. Okay, so that was 1, 2, 3, 4. So let's do each one of them over here. So the first one, if we do this, 2 times 2 is going to give us 4. 2 times root 3 is simply 2 root 3. Root 3 times 2 is again 2 root 3. And root 3 times root 3 is going to be 3. So we have all the numbers over here. So let's separate these numbers. We have a 4 and a plus 3. And all the surd terms, we have a 2 plus root 3 and 2 plus root 3 again. So if we look at these numbers, 4 plus 3 is 7. And 2 root 3 plus 2 root 3 is simply going to be 4 root 3 over here. So that is your final answer. So you should be in a position now to write this down, part A on your toolkit and subsection of basic laws. So write this down, pause the video, and this is what we have learned so far. Question 1, cool 1. Press pause, write these parts down A, B, and C, and press play when you're done. So part A, let's simplify this over here. So obviously we're looking at the crab claw method. Let's write this from actually over here. So 3 times 2, 3 times minus root 5, root 5 times 2, root 5 times minus root 5. And how you do this is up to you. Some students use the FOIL method. It's totally up to you. We use the crab claw throughout maths memory. So let's have a look at this. So 3 times 2 is going to be 6. 3 times minus root 5 is simply 3 root 5. Root 5 times 2 is going to be plus 2 root 5, and root 5 times minus root 5 is going to be 5. If you simplify these things together, we're going to do it over here like this. All the number terms, 6 minus 5, that will give us obviously 1. And then if you look at all the surd terms over here, we have minus 3 root 5 plus 2 root 5. That's simply like saying minus 3x plus 2x is minus 1x, or we'll say minus root 5 in this case. So that's the final answer, 1 minus root 5. Let's move on now to these questions over here. A bit different in nature. It's simplifying different numbers. Part B says root 72. Write this in the form of k root 2. Okay, so how do we find out k? Now, when you simplify a number, a little shortcut, a top trick is to always write the numbers, the square numbers should we say, from 1 to 36. 1, 4, 9, 16, 25, 36. So you should write this somewhere on your exam paper. Okay, so before you see the question, just write this down. We'll tell you why in a second. Now, let's pick two numbers that multiply to get 72. Now, it doesn't matter what numbers you choose, it does. You want to pick a square number and a non-square number. And saying that, we want to pick a number that's the highest square number and any non-square number. So, what number over here goes into 72 and the highest square number? Well, we could say it could be, let's say, 4. Could we go higher? 36. We could say this. We could say, how do you get 72? Root 36 times root 2, which would be 6 root 2. Now, it doesn't matter if we pick 36 or another number. It doesn't really make a difference. You just end up cancelling more, but always pick the highest square number. So when you see this, write this list down, 1 to 36, all the square numbers, and obviously pick the highest square number. 6 root 2 is your answer in this case. We'll do the same thing for part C. It says simplify root 108 plus root 27. Root 108, the highest square number, we'll write our numbers down again. 1, 4, 9, 16, 25, and 36. Let's now pick the highest square number that multiplies, that goes into 108. So this will be again 36 times 3, okay? Don't worry if you haven't picked the highest square number. You'll get to that stage, but it's much easier because it's less cancelling down. So this will give us root 36 times root 3. That basically is root 108. There are two questions in one, basically. Now, root 27. This is the same thing again as saying root 9. We're going to pick 9 this time over here, okay? Because that's the highest square number. Root 9 times root 3. So these represent both these respectively. Root 108 is root 36 times root 3. And root 27 is going to be root 9 times root 3. So you simply figure out the answers from over here. It's pretty easy now. So root 36 is 6. That's why we do that. 6 root 3 plus root 9 is 3. 3 root 3. We add these together. So 6 root 3 plus 3 root 3 is 9 root 3. That's your final answer for something slightly more complex, but still the top trick is to write all your square numbers from 1 to 36. There we go. So section B on Toolkit. So write this second subheading down, and it's called simplifying root x's. And remember to always list your square numbers, which are listed on the right in green, on the top right of the square. Press pause, please. Question 2, core 2. Press pause, write part A and B down, press play when you're ready. So this question is all about rationalizing the denominator, which means to make the denominator a whole number, okay? It's quite rare they'll say rationalizing the denominator in the exam. They'll probably say the word simplify, like over here. Let's get down to this. Rationalizing the denominator is all about rewriting the original question in a different fraction, by the way. And when you rewrite it, the denominator will be a whole number. We times the top and bottom by essentially 1. Now 1 can be written as root 5 over root 5, and that, as you've guessed it, is the bottom number. So whatever you see in the denominator, write in the top and the bottom. Now when you do this, you simply times top and bottom times bottom. 2 times root 5 is 2 root 5, and root 5 times root 5 is simply 5. So the final answer for this is 2 root 5 over 5. Simple as that. Part B, we're saying simplify 10 over 3 root 5. And this looks slightly different because we have an integer here and a surd. Now, how we deal with this, we can multiply everything basically by the surd only, i.e. this root 5 over here. We could do 3 root 5, but that's a bit more complicated. It'll be a root 5 over a root 5 over here. Let's do top times top and bottom times bottom. When you times two fractions, 10 root 5 all over. Now, there's an imaginary 1 here. So let's get this right. So when you multiply to, let's say, surds like this, we've got the numbers in the reds, and we've got the surd terms in the green over here. So let's do it like this. So 3 times 1. 3 times 1 is simply 3. I'll put 3 there in brackets. And root 5 times root 5 is simply 5. So it's 10 root 5 all over 15. That breaks down to 2 root 5 over 3. That's your final answer for part B. So go through this, make sure you understand this topic. It's not that difficult once you understand the basics. Question 2, core 2. Press pause, write these two fractions down, simplify these to your best, and press play when you're done. So parts C and D over here are, let's say, more complex versions of rationalizing the denominator. We have simplify 2 over 1 plus root 5. So why does this look different from the ones we've been doing before? Well, we have two different, let's say, terms here. A number term, and we have a surd term over here. Okay, so that's why it's different over here. Now, how do we deal with this? Now, first of all, let's put a bracket over this. Always put a bracket around two things. You see, when you have a number in a surd, always do that. You'll never do that in an exam. We multiply it by the negative sign, okay? If this is a positive, it'll be a negative, and it'll come quite apparent why we do that as we go along. So this will be 1 minus root 5 all over, again, 1 minus root 5 over here. Now, we times top, 2 times 1 is 2, and 2 times minus root 5 is simply 2 minus root 5. Now, we look in turn to the crab claw method and the denominator, and we multiply these out, and now you'll see why the minus makes a difference. 1 times 1 is simply 1. 1 times minus root 5 is minus root 5, plus root 5, and we have minus 5 over here. Now, this is simply the same over here. 2 minus 2 root 5 is your numerator still. Now, your denominator, we cancel a few things down over here. We have basically minus root 5 and plus root 5, which cancel. That's why these were the opposite signs, in fact. And 1 minus 5 is simply minus 4. Now, we can go even further with this. We can divide these separately. 2 over minus 4 minus 2 root 5 over minus 4, which would give us an answer of minus a half plus a half root 5. There we go. Now, you could write this in a better way. You could say this could be a half root 5 minus a half, or we could even go one step further, root 5 minus 1 all over 2. Okay, so look through that and make sure you understand how we got that answer. But that would be a final answer. It's the most simplified version, root 5 minus 1 all over 2. Let's do part B over here. So 2 over 3 root 2 minus 1. So again, we have two different things over here. We have 3 root 2 and we have the minus root 1. So we're going to get the positive version of this. So this will be 3 root 2 plus 1. And this whole thing will be over, same thing, 3 root 2 plus 1 again. Let's multiply the top bit. So 2 times 3 root 2 will give us 6 root 2 and plus 2. Now, the denominator, let's do the crab claw method on this. So just be a bit careful on this. Let's put a bracket over here to help us. 3 root 2 times 3 root 2, that's the same as saying 9 times 2. 9 times 2 is 18, okay? So make sure you understand that, okay? 3 root 2 times 1 is plus 3 root 2. And then minus 1 times minus 3 root 2 is minus 3 root 2. And minus 1 times 1 is minus 1. So this should give us an answer of now 6 root 2 plus 2. The whole thing is over, if you cancel a few things out over here, 18 minus 1. 18 minus 1 is simply 17. Okay, so just see how the two things cancel over here. So that would be a final answer over here. We have a prime or an odd number at the bottom. We can't do much with that. We would leave the final answer like that. So again, look through these questions. So if you get your toolkit out and go to section C, please, and write this subheading, rationalizing the denominator. So you should have understood two different types of using this technique. So press pause and write these two examples down, please. Question 3A, challenge. Press pause, write this question down. Try to get this answer over here, minus 2 brackets, root 2 plus 1. Press play when you are ready. So the first thing we're looking at this, which makes it a bit more challenging than the other questions, is this denominator having a fraction, i.e. root 2. So how do we deal a fraction within a fraction? Now the two methods we could do. The first method is we could use a method that we've seen before, which is to simply multiply the numerator and denominator by the opposite sign of the minus, i.e. we could do this 2 over 1 minus 2 over root 2 times 1 plus 2 over root 2 all over 1 plus 2 over root 2. That in theory would work, but that would mean a bit more cancelling and a bit more mistakes. So let's just shy away from that. Let's do a more simpler approach over here. So I would tend to use this one. So a method 2 is something you've actually seen before, probably year 7 and 8. So whenever you see a fraction, let's try to get rid of any fraction you can. When we see this root 2, we want to get rid of this fraction by multiplying everything inside by that number, i.e. root 2 in this case over here. We're going to multiply the numerator by that. We're going to get this 2 root 2 all over root 2 minus 2. That looks much better, in fact, because now we can multiply everything by the positive version in the denominator. Look how this 2 is the same as this 2 over here. It'll always stay the same. So we're going to multiply that by root 2 plus 2 all over root 2 plus 2 again. So root 2 plus 2. So let's do that now. We're going to do 2 root 2 times root 2 and 2 root 2 times 2. Let's put an imaginary 1 over here. We'll do this in a ordered way. 2 times 1 is 2, and root 2 times root 2 is 2. That's the first bit over here. The second one, root 2 times 2 is plus 4 root 2. So the whole thing over the crab claw method. So this would be the 4 steps. Root 2 times root 2 is 2. Root 2 times 2 is plus 2 root 2. Minus 2 times root 2 is minus 2 root 2. And minus 2 times 2 is minus 4. So this will give us 4 plus 4 over root 2. The whole thing would be over everything at the bottom, but simplified. Because you should be able to simplify these two terms over here. Hence, you're only left with 2 minus 4. 2 minus 4 is minus 2. We're left with this. Let's create this as two separate fractions. 4 over minus 2 plus 4 over minus 2 root 2. It's the same thing as saying minus 2 root 2. So then again, we could just simplify this and saying, let's take out minus 2 outside, minus 2, and this would be 1 plus root 2. And that's the same thing in essence as what we've got above. Minus 2 root 2 plus 1 over here. So again, the key thing was to look at your fraction in your denominator, and to get rid of it, we had to multiply everything by that denominator, which was root 2 in this case. So have a look at this. Method 2 is a much stronger way of doing this. Question 3B challenge. Press pause, write these two parts down, A and B. Press play when you have finished. So the first thing we see when we look at this is 1 over root 5 to the power of 5. And this power of 5 is actually confusing us because it's the first time we're seeing this. And you want to actually write this actually as a whole number. We're trying to say, how do we get from root 5 to a whole number over here to b? That's what the question is saying. How do we do that? Now, you know from common sense that if you do any fraction to the power of anything, i.e. to the power of 5 in this case, we're actually getting 1 to the power of 5 over root 5 to the power of 5. Now, does that make sense? If we were to do this, that would be your first line of thought. Do we get that whole number? No, we don't. So we're going to be a bit more creative in how we think about this question. So 1 to the power of 5 is simply 1. I mean, that's obviously anyone can do that. That's quite easy. But root 5 to the power of 5. How can we go about this? Now, in its entirety, root 5 to the power of 5 is saying we're multiplying root 5 5 times. We're saying root 5 times root 5 times root 5 times root 5 and times root 5 again. This is what the question is saying. Write this out the full way. Now, we can group this together as pairs because if you think about it, 5 to the power of a half times 5 to the power of a half, square root is a half, by the way, gives us 1 because we add the powers. So we're saying basically we can group these together because we have a nice even number as a pair. This is 5 to the power of 1, this is 5 to the power of 1, and this is simply the leftover bit, 5 to the power of a half. So we could say this, this is 1 over root 5 times root 5 is 5. Again, root 5 times root 5 over here is 5. and we have the leftover root 5 over here. So these green boxes actually represent these 5s over here. 5 times root 5. Now, obviously, 1 over 5 times 5 is 25. 25 root 5. So now we're coming to familiar territory where this looks familiar. Root 5 is in the denominator. Can we change that to a whole number? Yes, we can. We can multiply that by simply root 5 over root 5 over here. So this becomes root 5 all over. Now, imaginary number over here. 25 times 1 is 25. And root 5 times root 5 is 5. So 25 times 5 is 125. So there we have it. A is simply going to be A is going to be 5, and B is going to be 125. So go through that, make sure you understand part A. It can be quite tricky, but that's how you deal with a question like this. A is 5, B is going to be 125. So part B, express root 45 minus root 5 squared all over 5 times tan 30 in the form of a root 3. So when we see this, again, it looks complex because of this tan 30, okay? But you should know your trig tables by now offhand on a calculator. You should convert this into a fraction. But first of all, let's do this numerator over here. So root 45 minus root 5. Now let's first of all look at root 45 over here. You should know root 45 is a square number times a non-square number, i.e. a surd over here, which is the same as saying 3 root 5. We're going to now look at 3 root 5, and every time we see root 45, we're going to think of that. We're going to think of 3 root 5. So if we do this over here, let's just put a line here and think of it like this. So 3 root 5 minus root 5, all squared, and this will all be over 5 times tan 30. So 5 times tan 30. Now, when you see a squared here, you want to, obviously, common sense tells you to use a crab claw. Write it out twice. Don't do this. If you see the common unit over here, which is root 5, your common surd, which is root 5 and root 5, try to simplify this. It'll save you hassle. You'll get the same answer, but this is quicker. 3 root 5 minus 1 root 5 is simply 2 root 5. So 2 root 5 squared, the whole thing over 5 times tan 30. Now tan 30, you should know, is 1 over root 3. So we're going to write 5 times 1 over root 3 over here and put a little 1 there to make it the same. Let's do this over here now. Let's just use our numbers. I'll put a little red box over here and a green box over here to now expand 2 root 5. 2 root 5 squared will be 2 times 2, or 2 squared, 4, times root 5 is 5, and that will be on your numerator. Now, let's just make one big fraction over here. We have one big fraction, 5 over 1 times 1 over root 3. This would be 5 over root 3. So this is 20 over 5 over root 3. Now again, we've seen this scenario before. We have a fraction within a fraction. We have a fraction in the denominator. This root 3, we want to get rid of that. Let's multiply everything in sight by root 3. So the numerator, we're going to multiply 20 by root 3. So we get 20 root 3. And we're going to multiply this whole fraction over here by root 3, which actually gets rid of that, which is simply going to be 5. It's just a number on top, in fact. That's the shortcut tip. So 20 root 3 divided by 5 is simply 4 root 3. That would be your final answer for this question over here. So it does look tricky, but there are a few tips and tricks there which you can look at. That's how you do part B for that. And therefore A would simply represent, if we look at this, A would be this number 4, A would be 4. You could even say that. So this is how your completed maths memory revision card should look like now, and let's go through each of these key objectives in turn. So the first thing is your basic laws. You should have mastered, obviously, the 5 or 6 laws on this. Number 2, how you simplify the roots of certain numbers. You write all your square numbers up from 1 to 36. And thirdly, rationalizing the denominator. When your denominator is a surd, how to deal with that in different variations and forms. So again, let's look at our 3 key steps on these topics. The basic laws we've covered over here. Simplifying a root and simplifying a number where your denominator is a surd form. So let's turn over and remind ourselves of the key toolkits we've picked up from this, and let's head on with our Let's Do It questions. So let's make sure we now have our three sections clearly defined here, so we can create these Let's Do It questions. So sections A, your basic laws; B, simplifying a surd; and C, rationalizing the denominator. So pause this slide, make sure you have these, and let's now hit the go button. Question 1, let's do it. Press pause, write this question down, expand these two brackets, simplify this, and press play when you are ready. Press pause, write this question down, parts A and B. Press play when you have finished. Question 3, let's do it. Press pause, write this question down, and press play when you've finished.